Hello, everybody. So, who was this their first time seeing Aurora? Really? Oh my gosh. How do you feel different as a human? This is the first time I've seen pink in Aurora, so that was incredibly special last night, and hopefully we get to see it again. So, what is Aurora? Aurora is the term coming from Greek for goddess of the dawn, but it's also known in many other cultures by other names. And there's northern lights and southern lights, so depending on which hemisphere, you'll see Aurora borealis in the northern or Aurora australis in the southern hemisphere. And in order to understand it fully, we have to go back to the sun. So the sun has what's called a solar minimum and a solar maximum. And you might be able to tell the difference between the two is on the solar maximum, there's more activity going on in the middle of the sun. And when I learned what's happening, I remember also being blown away by this. The sun has a magnetic pole, north and south, but the equator of the sun is rotating faster than the poles. So it's like if you take shoelaces and you start twisting them and then it gets twisted, the magnetic from north to south is going to start jumping as that equator twist is tightening everything. And when that happens, you get these massive solar flares. The length of time that happens before it gets so twisted at the solar maximum, the poles, the magnetic pole of the sun actually flips. So instead of north and south, those change positions. And that happens on an 11-year cycle. So you'll tend to get more intense solar flares closer to the 11-year mark. And that solar flare, as you see here, NASA scientists who study Aurora like to call it a glitter bomb of photons coming towards Earth. So those photons hit Earth's own magnetosphere, which is protecting us from this UV light and sun and photons. And as you can see in this image, little tiny Earth is in the middle of the magnetosphere, and then we have our bubble. And the way the photons come into Earth kind of make that ring around the poles. So these photons, electrons, are hitting air molecules at different layers of the atmosphere. Those get excited, and when they're excited, they let off light. And then when they calm down, they're kind of bumping into each other, so they keep hitting others and letting off light. And then as they're coming into Earth's atmosphere, they lose that energy. So the reason we're seeing all these different colors is dependent on what layer of the atmosphere the light is being emitted and what gases are there. And oxygen and nitrogen are predominantly the reason you see either red or blue or green or purple. So oxygen atoms at the upper layer above 120 miles are emitting red, and then nitrogen and oxygen as well are emitting blue and green in the middle of the atmosphere. When they get lower down, below 60 miles, that's a nitrogen molecule that is emitting a pinkish color. And then if you're seeing other colors, it's just because the way the light spectrum works. On that far right picture, it's those primary colors blending together to make other combinations of colors. So you might have seen, actually every person's experience, we're gonna see different colors. And on deck last night, I heard some people asking that they thought it looked gray, or that why are our cameras able to see and make it look so much more vibrant? And the reason that happens is because of our eyes. We have rods and cones. Cones are what see color, and if the aurora is bright enough, then in that bright light, it will activate our eyes' rods, so we'll be able to see color. But if we have eyes that aren't so good in dimmer light, then our cones won't be able to be activated, so it might look more gray. Whereas a camera has the ability to capture that lower dim light level, so the camera is seeing the actual color, but it just might not be what your own eyes are seeing. So the camera's not lying in a sense. But I wanted to share that there are actually 4 types of aurora. There are discrete arcs, diffuse glows on the bottom here, pulsating patches on the far right, and then one called Steve. Before I get into Steve, I want to ask, which types did you guys see? kind of all 3 except for Steve, right? I don't think any of us saw Steve. So yeah, we saw discrete arcs. Sometimes it looked like a big sheet and you could see a distinct border. That's a discrete arc. far off, it kind of had a diffuse glow, and when the pinks came over and greens, it was diffuse. And then at one point, it was pulsing, and that was really magical. So Steve is a very endearing story. So it comes about from a group of hobby photographers who loved photographing Aurora in Alberta, Canada. And they kept seeing this arc that you see across the sky here. And NASA Aurora scientists were like, that's not a thing, that doesn't exist. They got more and more submissions. And finally, they looked at these photos and they went and confirmed that there actually is a new type of aurora phenomena that's occurring, where this arc is going, instead of like a north-south direction, it's going east-west. And it seems to only appear in photographs, not necessarily by the naked eye. And if it does, it's very, very dim and gray. And this was actually seen over 100 years ago by a gentleman named Carl Stromer, and he called it the feeble homogeneous arcs of great altitude. That didn't stick. So this community, there's a funny cartoon movie that came out around this time called Over the Hedge. I don't know if anybody had seen it. These animals are wandering around, wondering what about their life, and they come across this big green hedge made of leaves, and they're, what do we call this? What is this? We've never seen this. And one of the animals says, let's call it Steve. So in the photography community, when they saw this, they were like, what do we call it? It was a big Facebook group, and they're like, let's call it Steve. So that's where this came from. And so NASA, in order to honor the fact that it wasn't discovered by scientists, it was discovered by normal people, with their photographs, they honored the Steve name, and they called it Strong Thermal Emission Velocity Enhancement. So if you are interested in submitting any of your Aurora photos or contributing to more knowledge about Aurora, like Steve, or maybe some other auroras exist, there is a community science project called Aurora Saurus, and they are absolutely in love with any submissions you have, and they don't have to be in the moment. You can have them backdated. So if you submit, go on the website, you can submit your photos, and then they'll align it and track, and that helps improve predictions and forecast models and understanding of Aurora. And you also can go on their blog and the Learn tab and do beginner level all the way to intermediate and advanced. So auroras can help us understand more about space weather, electrical storms, power outages, how do they actually work, do animals respond to aurora, and can we predict them better, and more. You feel like a spiritual awakening as a different human, maybe, seeing these mystical, magical lights in the sky. Thank you, and I'm going to pass it on to